back to the keynote, which again I'll be talking more. This technology, say ML technology, is more relevant to the electricity sector. I'm end of the day lineman climbing poles, fixing your electricity connection. I start with the parting words of Mr. Mahendra Singh, who reassured that these new technologies are not going to destroy jobs. There may be some realignment, but these are going to create more and more jobs. And I would like to start with an anecdote. Approximately 40 years ago, when I started my career in Delhi, you can.
Sir, which one?
Yeah.
Sir, which one?
Yeah. Just go up and down. I just transfer to your.
Yeah, which one, sir?
Yeah, this one.
This one?
Yeah, that one. Exactly. So with NTPC in Nehru Place, we used to get salary on the last working day. The next day we used to take a checkbook and is it audible? No, he's just fixing this. Okay. Used to go to the bank and give a check. They give a metallic token. We used to stand there for an hour or half an hour, or depending on and big ledgers used to go from one table to another table and another table, and we get cash when the cashier called. The younger generation may not even know about it. That's why I'm describing. But in the afternoon, the lunch break in Nehru Place, 83, 84 and all that, I used to see. All the bank employees used to sit in the central plaza and say that stop bank computerization. The employees association were against bank computerization and they didn't want computerization. The only thing is that if computers comes, we will lose jobs. But despite that, the government went ahead and all the banks got computerized. It created more jobs. And many of you may not even remember when did you last visit your bank branch. You get money, you can do 24/7 all transactions. So same way, this new technologies which are going to come, in some areas people may be afraid that it may some of the jobs may be displaced. So in my slides also you will see some of the places where this is all the agenda which is given to me to talk about, but in this half an hour I have hardly time to cover only the first point, but there are several slides which I will share with the audience. You could go through it, write to me if for any further. So can you call the technician? Here it's not changing, it's only changing there. Professor Vijayaraghavan talked about AI commencing from the 1950s and the machine learning and the deep learning further hardly 10-20 years old technologies. So next chart, this is going to show last 2 centuries. I can't see this here, I can see only there. Here this is not changing. So it's a brilliant chart which somebody put together, how these things transformed or developed over the last 2 centuries. So which button should I use? Sorry about this. Both. इसमें आना चाहिए ना? By World Economic Forum, they predicted that currently larger share of the work is been up to 80% of the work is been done by humans and 11% or 21% or something is done by. Now I can.
Fine, sir.
Fine, thank you. So 29% of the work is done by machines as of 2018-19, and within 2025 machines will overtake us most of the work which we are currently doing. So this is a reality which is going to happen, and we all need to reskill and relearn to get into it. The artificial intelligence workflow starts with data preparation, AI modeling, simulation and test and deployment. This is a process through which we deploy artificial intelligence for any application or any domain. So in the power sector, particularly from generation to transmission to distribution to customer and the enterprise level, these technologies are used for optimizing the power plant operations, optimizing the grid planning, the distribution grid, optimizing the emergency response zone, outages, storms, vegetation management. All kind of activities can be optimized and improved drastically with these new tools. So and customer area. So many use cases are there. I'm not going to get into the details of that. In the smart metering or the advanced metering infrastructure itself, there are 33 use cases of AI and ML. So the grid analytics, how do we use for different activities? So next slide will give you better what are these analytics and how these are. The descriptive analysis are basically business intelligence and data mining. So condense data into smaller, more useful nuggets of information and analyze them in real-time data and historic data to predict what is how to plan for the future actually. So this is descriptive analytics, and the predictive analytics is basically forecasting what might happen in future, and these are all probabilities in fact, and give answers to questions that cannot be answered by the business intelligence. So and data reduction. So what will happen if a particular condition happens next? That is predictive modeling. Why this happened? That's a root cause analysis. Identify correlated data, which is data mining. What if some trend continues? The present trend continues, what will happen? That's forecasting. And what could happen in an unknown scenario? And that's Monte Carlo simulations help us predict those things. When would an action be invoked? That is taken from the pattern identification and give alerts. This is how this predictive analytics is utilized. Prescriptive analytics is basically for simulation and optimization. This optimization that help achieve best outcomes. Stochastic optimization to understand how to achieve best outcome. Identify data uncertainties to make decisions, and reduce duplications and readmissions. For example, calculating the credit score of a particular customer, how likely he is to pay installments on time of a loan. So this is a maturity model of this analytics. It's a primer. I won't go through it again. You can read it, how each of these things come to a maturity level. Here I take a minute to explain the simple automation start with desktop automations. In computer, many of the applications you have on the desktop can be automated. The simple data migration, those kind of things which you could do that. Rule-based process automation is robotic process automation. Things which are repeatable, predictable, measurable. Those operations can be completely much better than human. You are actually eliminating human error by RPA. Most of the enterprise applications which we do can today be done on RPA. And this is when the data structure exists. When you don't have data structure, the RPA becomes difficult. Then you come to an autonomic process automation. Here you deal with a more moderate to high exception rate when bundled with RPA. So this predictive reasoning still cannot be done here, but when you move to the cognitive process automation, which is even unknown territories, you could be able to automate things. A self-healing process that models learn from itself even in an unstructured patterns. So coming to machine learning, the first step is to gather data from various sources, clean the data to have homogeneity, model building, and select the right algorithms and gain insight from the models, train the models basically, and then deploy the models. So here machine learning can be broadly classified into supervised learning. There again, when you know the data structures, you use supervised learning. When the data structures are not known, it's unsupervised learning, where big data handling with big data is you try to cluster them, dimensionality reduction. These are all different techniques used with each one of these techniques. So reinforcement learning and deep learning are other areas which are evolving of late. So here many of them I am again talking with respect to the power sector operations. What are the supervised learning, unsupervised learning, deep learning and ensemble learning? What are the techniques and what are the potential customer problems, and what are the applications for which these are used are depicted in this slide. And you could read it. The organizers will share all this deck with you. So some of the programming languages which has evolved, which is making this AI and ML possible today, easy for anyone to do, is Python language, Java, Lisp, R programming, etc. And this can be, many of these AI tools can be classified into basically open source tools and COTS, commercially off the shelf tools like your Office, Word, Excel, SAS, MATLAB things. These are all commercially available. You have to pay money to those people, you have to pay royalty, maintenance charges, etc. But advantage with these tools are that the trained people are available in the market. You can hire with the code software, you can hire people from the market, you get trained people. All the companies which have done these things, they have developed they undertaken training to develop a skilled workforce. Then open source things which are available like Python, Java, here again there are a lot of training programs available both online and offline, and some of the most popular ones are there. And the libraries, why things have happened in last 10 years is because of the libraries which are available. These are all TensorFlow, Scikit-learn, Keras, these are all libraries which are available. You could simulate anything which you want and you can run it in those libraries. Datasets are readily available, almost similar datasets. If for a particular application you don't have your own data, you could take it from these libraries and develop your application based on that. So supervised learning we use in the power sector for revenue maximization, customer risk scoring, etc. Unsupervised learning for customer profiling, segmentation, hands-on learning, loss reduction, fine theft identification, commercial and technical losses identification, etc. Automated machine learning we use for procurement strategy with impact on distributed generation, etc. Deep learning, solar module image analytics, meter reading analytics. So deep learning further get into RNN, CNN, ANN, etc. Recurrent neural network. These are basically influenced by the psychological behavior. The models are trained based on psychological behavior of the people or target clients or customers involved in that. So regression techniques are basically, I'll come to which are the algorithms, machine learning algorithms. So first one is regression techniques, which are basically dealing with numbers. Linear regression, polynomial regression, advanced regression. These are things which we use for the SCADA data, alarm analytics, transformer monitoring analytics, etc. So classification, we classify into A or B or C. So those are the classification which happens, which is naive-based. There are several algorithms are used for the classifications depending on the data. Decision tree, random forest, support vector machine, logistical regression, KNN, ADA boost and XG boost, etc. Then clustering, that is for customer profiling and segmentation, etc. Here again there are a lot of algorithm we use it. K-means clustering, and LDA, collaborative filtering is another area, and dimensionality reduction. Particularly these are used in data sets which are not structured, big data. We try to reduce the dimensionality so that we can handle them in smaller nuggets. And deep learning comes to CNN or convoluted neural network. We use it for electricity meter data. You look only once is pretty new, last 2-3 years only YOLO emerged, but RNN and ANN are extensively used in different domains. So we on the right side, power utility domain, which are areas we use these techniques. And coming to robotics, there are robots are, once they have been deployed for a particular job, they are much more efficient than human beings. They don't need breaks, they don't need off, they don't need they can be in environment which are very hot, very humid. It can be deployed in air. They're not worried about air quality. They don't need toilet breaks. They don't need overtime. So these are much more efficient once you do that. So in power sector, we use them for cleaning and maintenance. We have mobile robots for inspection and monitoring from the ground. We have suspension robots for high voltage transmission line inspection. We have drones. We fly drones for remote on the transmission lines and distribution lines. And here it's not the ability of the camera or the drone which is basically helping us. It's the analytics behind that, the pattern recognizing. So last year in Delhi, in one of the distribution companies, a company had done a drone-based inspection, and we could come out with almost 36 different faults, which either from naked human eyes we would not have been able to identify. It's a line in Okla, some 11 kilometers we had flown the drones to see that, and the analytics brought out 36 different fault. Some of them could have ended in less than few months. It would have ended up in some outage of the line itself. We could repair those things. And manipulator robots were repairing interaction, etc. So all lot of activities which could be done in robotics. That itself is a much larger chapter. Won't go into the details. Some of the use cases which I in some slide talked about it: generation, transmission, distribution, and consumption. We have different use cases. Revenue maximization is the best thing which we do from the data which is collected from the billing data and meter reading data which is available from the data lake. Different tools are deployed to find out what kind of a revenue will have in the next month or the following months. So another one is from the individual customer behavior. We know who is likely to default, who is likely to pay on time, who is likely to pay before the end date. Those kind of dashboards are being created from the segmentation of the data. And coming to loss reduction, finding pilferages. So we use that tool called random forest approach and a couple of other approaches. So algorithms used in this is basically the random forest support vector machine, KNN and ANN tools which are used to find out how the pilferages points can be identified, it can be addressed to. So here there are 10 different analytics from the alarm data of the high voltage line tripping analysis. This is actually the past data, historical data of fault which happened. How do we analyze and come out with more intelligence so that it doesn't recur, take preventive actions for future. So there are about 7-8 different things which we do here. I won't again go into the details of each one of them. These slides were, sorry. So distribution transformer monitoring. This is some of the equipment which are on the street basically, which are prone to overloading, prone to all kind of interference from people, and this is the one basically in a power system prone to maximum fault and which brings maximum inconvenience to customers. A distribution transformer outside your street, it goes fault, the entire street nobody has electricity, and somebody makes call and then only we know that okay, there is a problem from the grid, somebody comes to inspection. But in the complete smart grid scenario, even before a call comes to the call center, we'll be able to find out that the system in a smart grid where everything is monitored in real time, we would have the call center operator would have the exact data that this is the problem, and I already the workman has been dispatched within 2 hours or 4 hours, it will be taken care. That is the future, we are working towards that. So there are from the past data and the real-time data from distribution transformer monitoring units wherever it has been deployed, we are able to do many of the analysis of the fault, different type of fault, area-wise, different voltage levels, different customer area, breakdown analysis, how much time we took to restore them, etc. And outage, what all outages happened and which area it happened, how many customers been affected. These things, the tools brings us nice dashboard to different levels of the management. They could take appropriate action to ensure that things are taken care in future. And this is basically the network reliability analysis, which is system average interruption duration index. एक महीने में कितना घंटा बिजली गया तो भी how much time it took to restore it. So customer average interruption duration index, these things are monitored here also, but as I had mentioned, data collection is still not completely 100% automated. So some amount of human intervention is there in the data collection, which means the data is not 100% reliable. So our utilities giving to the regulators the KD numbers are not exactly the current one. Although you may see that all year there was only 10 hours of power interruption, but actually it was much more each one of you. So we hope that in the next couple of years, when the smart metering will be done compulsorily all across, this SAFE, KFE numbers will be actually captured by the system without human interference, and we will be able to monitor it. This is from the call logs, from the today in India also we have a very good call center in all the urban areas. We have a 4-digit complaint number 1912 all across India. We have 1912 is the electricity complaint, which we have been advocating that should be extended to water distribution, gas distribution, as well as other smart city operations as well. So from the analysis of the call logs or calls, many of these call centers are also now digitized. They have chat bots, they have voice bots, and from there some of these RNN techniques are used to predict what is the kind of calls which are coming. LSTM network means long short-term memory. So this algorithms generally help us in finding out maximum call come for what kind of a complaint, and that can be taken care from there. And many of them will be able to. This is about predicting the energy market. So different tools used to predict what would be the demand for tomorrow, and which one actually follow the actual. Actual is different. So the green one, the black one is the actual one. Which tool could come more closer to or predicting that? These are all being utilized. Balancing of power procurement strategy with the impact of distributed generation, how much solar will be there, and what is going to be the solar generation tomorrow. That depends on solar or wind generation, hugely depend on the weather for the next 2 days or 3 days. So we should be able to forecast that more appropriately so that other generation sources can be scheduled for generating in those times. And this is a very interesting solution which a startup in Delhi came up with. Last year during the lockdown, nobody wanted a meter reader to come inside your house to take a meter reading, and neither people were there available to come to your houses. So what utilities across the country have done, they have given an average estimated billing. And people actually spend more time at home rather than in office, particularly in the summer last year, and everybody's electricity consumption gone up, and utilities made some estimated average and billed them, and there are a lot of hue and cry all across saying that my bill has inflated. And there was no way for a utility to prove that it has actually gone up, because they were not sending meter readers to everyone's house. So some people have come out with different solutions. This is a smartphone based application. You open the app, take it and hold it right in front of your meter, and it calculates. It connects back to the back end of the utility, and what was the last bill generated reading compared to the today's reading when I am doing this app, and it generates a bill and give you on the phone itself, and you have an option to make the payment from there if you want to do. Otherwise you have a bill, you can go to the online and make the payment to the utility, and a bill is generated in the utility as well. This is a very interesting thing which has been piloted in Delhi and a couple of other places, both for gas, for electricity, water, and many other countries are also now adopting this method. I won't get into the details. Building energy management system is where AI, ML techniques are used extensively now, and the return on investment is less than 1 year in many of these things, in energy management systems in buildings. And electric vehicles is another. Charging of electric vehicles. You come to the office, you plug in your electric vehicle, and you can program it such a way that you charge from the grid when the price in the grid is less. Today you all pay flat fee, but very soon it is going to be real-time pricing for electricity. So every 15 minutes, 30 minutes, prices may change. You get a price signal which will be available. So you can program your car to charge the battery when the price is below 5 rupees per unit of electricity. And you can also say sell it back to the grid when the price on the grid is more than 8 rupees, but keep enough to drive 25 kilometers back home. So this are today's technology possible. It's been done in places as pilot projects, but more importantly, why we need this thing, the integration of the electric vehicle with the grid, is because there is variability in the solar and wind generation, and millions of electric vehicles which are connected to the grid can be aggregated as virtual power plant. Battery can pump electricity back. It could help maintaining the grid stability. So I stop here, and there are many slides which are in the backup. At least 20 slides are there which go through it. Anybody has any questions, we'll be happy to write to us. If anybody has any burning questions, you can ask now. Yeah, 1 minute. Thank you very much.